Good morning, students. Today we are going to see the lesson Thermodynamics, Unit 7. In this lesson, we are going to see thermodynamics. It means flow of heat, and it is derived from the Greek word thermo. Thermo means what? Heat, and dynamic means flow. It means heat flow. So, in thermodynamics lesson, we are going to see the heat flow. So, the power of heat flow, is nothing else. The word thermodynamic Greek word, and power of heat and force we are going to see. So it means the capacity of hot bodies to produce work. It is given by the scientist Carnot, and he gives the Carnot engine how it is working, how it is produces heat. Everything is explained to him in this lesson. Carnot engines which produces heat, not only for Carnot engine, all the machines which can produce heat energy. So in this lesson we are going to see the heat flow, that means thermodynamics. So in this, we come across many useful reactions. So, first of all, day-to-day life, we are seeing the burning of fuel to produce heat energy. Petrol, diesel, it produces heat energy. And flow of electrons through the circuit. It produces electrical energy. So, flow of circuit. If you switch on the light, it will be glittering, isn't it? Likewise, the flow of electrons is the reason. So, heat, this is also heat flow. Metabolic reactions to produce necessary energy for biological function. Example, we can see photosynthesis process. In this photosynthesis process, what happened? The light energy is essential to produce the food, isn't it? Preparing food. So here the flow of electrons, the chemical energy is converted into food. So again, thermodynamic study of transformation of energy is important. So it explains all such process quantitatively and allows to make such predictions. So we shall see some more examples for the energy transformation. So chemical energy, some chemical energy converted into mechanical energy. Whatever we are eating, it will be converted into chemical. It just gives the essential energy to move. That is what mechanical energy. And radiant, I told you already, photosynthesis process, the light energy is important. This is also heat flow. The flow of electrons will be converted into chemical energy to prepare food for the plants. Chemical energy, it is what actually a fuel, a diesel or petrol. It is one of the fuel. This is must be essential to give the mechanical energy, as well as the flow of electrons in electrical circuit. It is also gives the heat energy, that means what? Thermal energy. This is known as energy transformation. So understand, children, this lesson we are going to see a thermodynamics. It means heat flow. So in this 19th century, so in 19th century, already the scientists tried to understand principles of steam engine which were in operations in order to improve their efficiency, how it is working. And the basic problem of the investigation was the transformation of heat into mechanical work, how the heat energy is converted into mechanical work. However, over the time, the laws of thermodynamics were developed. It means later you are going to learn first law of thermodynamics, second law of thermodynamics, and zeroth law of thermodynamics, whatever you are going to learn. In these laws explains, understand the process of steam engine, how it is working, how the heat energy is converted into mechanical work. And these laws have been used to deduce the powerful mathematical relations applicable to broad range of process. So, in this lesson, you are going to learn thermodynamics. And students, in this thermodynamics, already I told you it is not heat flow, isn't it? So, you are going to learn some more new terminology in this lesson. That is what? System, as well as surroundings, as well as boundary of the system. So you can imagine if you are playing a cricket and the ball went to boundary line. Did you hear that word, boundary line? So you can imagine the ball is a system and the ball is a system. So you can imagine. Or else if you are pouring some water into the water bottle, the water is a system, right? And whatever outside the system, that is said to be surroundings. So the system as well as surroundings which is separated by one line, that is what? Boundary. Suppose the cricket players are inside the cricket, inside the cricket playground, they consider as a system, and you are sitting in the chair, isn't it? So that is said to be surroundings. You are as well as the cricket players, which is separated one line, no? That line is said to be boundary. Just you can imagine. And this system as well as surroundings, it is also, we have to say simple thing. So this is system and surroundings as well as boundary line. So simple thing, we are going to see the system, a quantity of matter or region of universe under thermodynamic consideration, and the system is separated from the rest of the universe. And boundary line, we can say the real or imaginary layer, this real or imaginary layer, the system from its surroundings, that is what it is, boundary line. You can imagine cricket or some other thing, or you can take a water can, you can take a different box, anything else which is kept inside that, that is what system. And one is separated from the surroundings, that is what boundary line. It may be a real or imaginary. And surroundings, if you are seeing whatever in the universe, that is what surroundings. Surroundings, we can say everything in the universe that not a part of a system. This is surroundings, and consider all thing is known as surroundings. So not a part of a system, that is said to be a surrounding. So understand, first one system and boundary line as well as surrounding. All together we are going to see that is what universe. We are in universe. So everything is in a. So the system is also classified into two, one is homogeneous as well as heterogeneous. Homogeneous, you already heard that word. A system which consists of single phase is known as homogeneous. For example, a mixture of gases and mixture of liquids, if it is in same phase, that is what is system. It's a homogeneous system. Heterogeneous means what? It is differ. A system which consists of two or more phases, that is said to be heterogeneous system. You can say many examples, sand with the water, or also mixture of oil and water. It is also, we can give some, this is also considered to be a system. And the system once again classified into three types: open system, closed system, as well as isolated system. So open system as well as closed system, we shall see here open system and here closed system as well as isolated system. So the open system, we can see exchange of, that is, this is matter. Here matter as well as heat. The open system exchange mass as well as energy is usually in the form of heat with its surroundings. You can take a water bottle, you can take a tumbler of water. So you can exchange the matter as well as you can touch, you can feel whether it is hot or cold. Isn't it? That is what open system, which can be exchanges both matter as well as energy. That is what open system. It is a open water can or open tumbler or anything else. And closed system, it is already closed, isn't it? So closed system which allows the transfer of energy but not a matter. So if you are taking your food in a tiffin box, if it is closed, isn't it? Automatically you can touch the tiffin box, you can feel the heat alone, not the matter, right? So it is what closed system. So the matter cannot be exchanged because it is already closed. Then isolated system. This isolated system which does not exchanges both because of the outside is insulated. So neither exchange matter as well as energy. Both cannot be exchanges. That is what isolated system. We can see some few examples for isolated system. We can see a thermos flask we are using day to life. Whatever we are pouring inside that, whether it is hot or cold, it must be as it is. That means it is isolated system because of it is isolated. Matter as well as energy cannot be exchanged through the surroundings. Closed system, already I said, a cup of soup with a lid, example we can say a tiffin box, anything else which is closed on the top, so we can feel only the energy. So it exchanges only the energy to the surroundings, that means heat. Open system, open soup or open tumbler, anything else we can say, both can be exchanges, matter as well as energy can be exchanges. We can take many examples for that. So students, in this topic you are learning system, surroundings as well as boundary line. And in this topic you must remember this, what are the types of system: isolated system as well as closed system as well as open system. Thank you students, we will see in the next topic.